Good morning. Namaste. How are you? Can you hear me? Was there any homework? Was there any homework?
Sir, I can't hear you. Good morning, sir. No, sir.
Good morning. Can you hear me? Can you hear me, Anurag? Can you hear me? Anurag, David,
Sir, can you hear me?
can you hear me? Am I audible? David,
Sir, I can still not hear you. I resigned.
I'm not getting any response. Can you hear me?
Yes, sir. Yes,
Okay.
sir. Now I can hear you.
Okay. So, good morning once again. Namaste. How are you doing?
Good morning. Good morning, Mr. Sir. I am fine.
Was there any homework?
Not yesterday, sir.
Okay.
Not yesterday.
Anurag,
Before that was something. Sir, I didn't get. Before that was something.
well, let us move on. So the first question is, check if two thousand 304 is a square number. How to check it? Can anyone tell me what's the method to check it?
So, prime.
David, you tell me.
Not one after prime.
So you don't want to say it in detail. So if I teach you everything in shortcut, that will be okay?
No, sir.
Why are you behaving like a duffer? I asked, tell me the process.
Sir, we divided by the smallest.
David, you know it or not?
I know it, sir.
You know it and you don't want to tell it.
Sir, we do first prime factorization, sir. And
First you will do prime factorization, and what after that you will not tell me, right? You will only tell me first what will you do. Second, what will you do? You will not tell me. Third, what will you do? You will not tell me. Do you mean that? First we will do prime factorization, and what after that? Nothing. No idea. A big liar. Still kept quiet. Submit within 2 minutes. Show it. Submit your work. You completed?
Yes, sir. I have completed. I'm submitting.
Okay, submit it now.
Sir, I have submitted. Yes, sir.
So what is your answer? Yes or no? Where is the answer?
Yes, sir. I have submitted. Sir, with the dual proof, sir. My answer is no, sir.
Where is the answer?
No, sir. My answer is no.
Why have you not written it?
Paper was written.
Very careless. Very dull brain.
Sir, there was no, sir.
You don't even could learn prime factorization. This is the prime factorization you did. Very poor. Very disappointing. 2 squared, 2 squared, 2 squared, 2 squared, and lastly 3 squared. Since all the factors have a square, so it's a perfect squared number. How poor you did. You divided by 11 and got 14. You can never learn what is taught to you. Now, finding a square root of a number. Finding square root of a number. Let us understand first what is a square root. What is the meaning of a square root? See, square and square root are two inverse processes. First is a square and second is a square root are inverse processes. How so? If 11 square is 121, then we have a squared 11 and we got 121. Now the result 121 will be having a square root. Square root of 121 is equal to 11. Just opposite. The square of 11 is 121. The square of 11 is 121. Then the square root of 121 is 11. Just reverse. So 11, 121. We square it and we get 121, correct? So if we go reverse in opposite direction this way, square root, in shortcut I have written SQ, SQ for square. If you square root 121, you will get 11 back. Just opposite process. Does this make sense?
Yes, sir.
David, you don't lie. I don't believe anything makes sense to you. You never do the things correctly. I taught prime factorization and you did that. Spoil. So squaring a number gives us a result. When that result is under a square root, we get that number, starting number, initial number back, 11. 11 when squared we get 121. Now when this result is a square root, under square root we get 11 back. For a square, how do we write the symbol? We put a power 2 and we say this is a square, right? Similarly, for a square root, we make this symbol. This is the symbol for a square root. This is the symbol for square root. So if we have to square 11, we write 11 and we put power 2. This is called squaring. This is called a squaring. The result is 121. Now this result is under a square root like this. Under a square root, the result comes 11. Is this meaningful?
Yes, sir.
Notice that inverse operations, when inverse operations come together, they cancel each other. Whenever inverse operations come together, they cancel each other. That's a rule. Whenever inverse operations come together, they cancel each other. They cancel each other. So if you have square of any number may be in this place, if you square that number and the whole thing is put under a square root as well, the two operations came together. The square is inside and the square root is outside. They cancel each other. You need to remember that's a rule. Whenever inverse operations come together, these are two come together. Maybe square root is inside and square is outside. Any number can be in this place here. Any number can be there. Let us take that number A. So only A will come out. Only A will come out. Because square and square root came together. They cancelled each other, only that number remains as a result. Is that meaningful?
Yes, sir. Yes, sir.
Not to you, David, right?
Yes.
Very disappointing guy. You always say yes and you always do no. Say yes, do no. Say yes, do no. You always say yes, you always do no. When it is time to show your work, it becomes no. But when it is time to say something, It is yes. So whenever square root and square come together, let's see some examples. Like any number, I'm taking 5. I'm taking 5. First, I
there is
square
no
it.
all coming.
First, I square it, and then I put a square root over it. Only 5 comes out as the final result. Similarly, if I write 5, I put it under a square root and then I square it. Only 5 will come out. So you need to remember this rule. This is how it works. The square and the square root are the two inverse operations. Whenever these two come together, these two cancel. Both of them got cancelled. The square root and the square both gets cancelled, and the number which is inside remains there. 5 is there, 5 remains. The square root and square got cancelled. Here also the square is outside, the square root is inside. So it doesn't matter which one is inside, which one is outside, they cancel each other. Only that number comes out. And this is why if we want to find the square root of 2304, if we want to find a square root of this number, we use that technique. We use this fact as a technique. This fact itself becomes the technique. We know that a square and a square root cancel each other. So, to find the square root of this number means what? Finding square root of 2304. If we are finding a square root of this, this means we are trying to find a number whose square is 2304. This is the meaning of finding a square root. If you are finding a square root of 2304, that means you are trying to find that square of which number equal to 2304. Getting the idea? That number will come here in this place. Same number will come in these two places. Suppose here is a number whose square is 2304. So a square root of that will be this number. Once again, see the statement. Finding a square root of 2304 means we are trying to find a number whose square is 2304. So let us check square of which number is this. We already have seen the prime factorization of 2304. 2 square, 2 square, 2 square, 2 square, 3 square. 2 is available 4 times, 1, 2, 3, 4, and 3 is once. We know that 2304 is equal to 2 square times 2 square times 2 square times 2 square times 3 square, right? So this is what we got when we prime factorized 2304. And as an exponent of laws of exponent, you know that if a into b has a power m, you can write it like a power m into b power m. We have studied this law of exponent or not?
Yes,
If we have different bases to multiply and their powers are same, we just multiply their bases together. We can write it reverse order also. I mean that on the left and this on the right. A power m into b power m is equal to a into b raised to the power m. That's the same thing. You write this way or this way. That's the same thing. No difference. If you have different bases like a and b with the same powers m, so what you do, how you handle it? You multiply the two bases together and you write that power only once. The same thing you will do here as well. We have different bases, like here is 3 and these bases are same. That base is different, but all of them have same powers. So let us multiply all the bases together. 2 times 2 times 2 times 2 times 3. And square is common power. Let's write that only once like this. We followed this law of exponent, isn't it? Now if we multiply these numbers, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 3s are 48. So it's 48 square. Now we understand 2304 is equal to 48 square. So 48 came here. 48 square is this. That means a square root of 2304 is 48. Got it? See this one more way. What we can do is, under the square root, instead writing 2304, we can write the factors of it. These factors. So 2 square times 2 square times 2 square times 2 square. 4 times and then 3 square. I wrote all the factors. Is there any problem? 2304 can be written this way. Now notice the square and square root will be cancelled for each of them. First 2 has a square, it gets cancelled with a square root. For second one, the square root and square got cancelled. For third one, again square and square root got cancelled. For fourth one, square and square root cancelled. For the last one, square and square root got cancelled. That square root was common for both of them. So all these squares got cancelled with square root, and what comes out? 2 2 2 2 3. 2 times 2 times 2 times 2 times 3, which is 48. Because we understand a square and a square root cancel each other, we used that process here. If you have any question, let me know.
no question.
Now if a question is like this, find the square root of 2304, we have not that 784. Let's take a different number, 784. If we have to find out a square root of 784, what we will first do?
So we will first prime factorize.
Right. So we are learning prime factorization method. Prime factorization method to find square root. Prime factorization method to find a square root. Well, step 1. Let's write it here on the side. Step 1. Prime factorization. Prime factorize 784. Let's do the first step. If we divide it by 2, it's an even number, it will be cancelled. 2 3 ja 6, 2 9 ja 18, 2 2 ja 4. Again even number, so by 2, 2 1 ja 2, 2 9 ja 18, and 2 6 ja 12. Again it's even number, so again by 2, 2 9 ja 18, 2 8 ja 16. Again by 2, 2 4 ja 8, 2 9 ja 18. And then comes 7, 7 7 ja 49, 7 1 ja 7. So what we notice is 784 equals 2 square, 2 square into 7 square. So if we want to find a square root of 784, make the symbol of a square root like this, 784. What actually we want to know? We want to know a square root of 784. Means what? Means we want to know whose square is 784, whose square will be 784. So make a bigger square root sign, inside which write all the factors of 784 with a square over them. 2 square, 2 square, 7 square. I mean, write all the factors of 784 like this. Now all these squares will be cancelled with the square root, because square root is common for all of them. The square also is for all of them. The square root also is for all of them. So all the squares and all the square roots got cancelled. We have now 2 times 2 times 7. 2 times 2 times 7. Just multiply and you get the answer. 28. So 784 is the square of what? 28. That's why the square root of 784 is 28. Is this okay?
Yes, sir.
Step 2 was cancel out square and square root. So this is the method to find out the square root of a number 28. But this method has a problem, you know, limitation of this method. See the limitation of this method. Limitation is that if a number is not a perfect square number, then you will not be able to find a square root of that. It works for only for perfect square numbers. That means it doesn't provide the value in decimal. It doesn't provide the values in decimal. For example, 144 square root. What do you think it is?
12. 12. The 12.
And what is the square root of 169?
The 13.
What's that?
The 13, sir. Sir, I said 13.
Okay. Both of you said 13?
Yes, sir. Yes, sir.
Now, if we want to have a number that is greater than 144 but lesser than 169, can you suggest me any number which is greater than 144, lesser than 169?
Sir, 152.
152.
Sir, 152.
Notice that 152 is greater than 144 but lesser than 169. That means their square roots also will be in the same order. The square root of 152 will be greater than square root of 144 but lesser than square root of 169. 144 square root is 12. 169 square root 13. Square root of 152. Do you know any whole number between 12 and 13? Any whole number?
No, sir.
There is no whole number which is greater than 12 but lesser than 3. What does that mean? What does that mean? What does that mean?
Sir, that means square root is not a whole number.
Not a
Whole
what?
number.
Right. So what it is?
Sir, a decimal number.
Exactly. So square root of 152, which is greater than 12, lesser than 13, is not a whole number because there is no whole number between 12 and 13. Since there is no whole number between 12 and 13. There is no whole number between 12 and 13. So, square root of 152 is not a whole number. Is not a whole number but a decimal number, right?
Yes, sir.
So, if we want to find a square root of 152, Using prime factorization method, this method, we cannot find the square root of 152 using prime factorization, because prime factorization never gives us the decimal value. I have mentioned it here. It doesn't provide the value in decimal. So this is the limitation. Limitation means it has a limit to work. After that, it doesn't work. What is the limit? It works for only perfect square number. Okay, now the question is, check if 4096 is a perfect square number. Perfect square number. If yes, then find the square root of 4096. First you have to check if it is a perfect square number. If yes, if you think yes, then you have to find out a square root of 4096. You have 4 minutes to submit. Show that you got it. If you understood, show it. Prove it.
Yes, sir.
Don't say yes, sir. Prove it.
Sir, I'm done. I'm submitting my work. Sir, I have submitted it. No, sir, almost. Sir, I have submitted it.
Okay, got it.
I'm on.
No matter how long time I give, that becomes smaller for you.
Yes, sir. I'm on.
4096 divided by 2. 2 2 ja 4, 2 4 ja 8, 2 8 ja 16. By 2 again, 2 1 ja 2, 0 remains 0, 2 2 ja 4, 2 4 ja 8. By 2 again, 2 5 ja 10, and 2 1 ja 2, 2 2 ja 4. By 2 again, 2 2 ja 4, 2 5 ja 10, 2 6 ja 12. 128, 64, 32, by 2 again, 16, 2 8 ja 16, 2 4 ja 8, 2 2 ja 4, 2 1 ja 2. So 4096 is equal to what? 2 square, 2 square, 2 square, 2 square, 2 square, and 2. So we see all the factors are having square. That means it's a perfect square number. Since each factor is squared, so 4096 is a perfect square number. So first answer is done. Question was telling, check if this is a perfect square number. We got yes. Now let's write it in brief only. Yes, 4096 is a perfect square number. Now we have to find the square root of it. Second part starts here. Square root of 4096 equal to what? So under the square root sign, we have to write all the factors of 4096 like this. 1, 2, 3, 4, 5, 6. 6 times. 2 square into 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 2 square. Now all the squares will be cancelled with the square root, and we have only 2 times 2 times 2 times 2 times 2 times 2, which is 2 is 6 times, so it's 64. 64 is the square root of 4096. Got it? Any doubt? Any question?
Yes, sir. No doubt, sir.
Now let us learn shortcut to square a number. Shortcut to square a number. Consider a number in which number with ones digit b and tens digit x. Tens digit a. So what is the number? I am writing like AB. Let's write the number this way. I have put B at ones place, A at tens place. So if you have to square it, what you need to do is, you will do B square, then here plus sign, then you will write here 2 times A times B, and then A square. Plus sign is here again. See the example to get it in more detail. Let us understand how this process works. Suppose I have to square 23. What is B and what is A?
Sir, A is 2 and B is 3.
Exactly. So here it is. In place of A, I get 2. In place of B, I get 3. Okay. B is 3, A is 2. So what rule says? You have to start from the right hand side, B square. B square first. So 3 square. What is 3 square? Then you will write here 2 times A into B, means 2 into 3. 2 times A into B. So 2 times 2 into 3, and then plus sign, A square, means 2 square. How to calculate? What is 3 square?
Sir, none.
Is there any carry forward? Any carry forward? Any carry forward?
No, sir.
Now 2 times A into B. 2 times 2 times 3. What is that?
12. 12. Sir,
What is
12.
that?
12. Sir, 12.
And there is no carry forward. So only 12 is there. If there was any carry forward, we have to add with 12. But there is nothing carry forward. So only 12. From 12, we have to write 2 there and 1 carried this time. 1 is carried forward to the next. We got here 2 and 1 carried forward. Next is 2. 2 square is
4.
what is 2 square? 4. And what was the carry forward? What was carried forward?
Sir, 1.
1. Add them and tell me what is to write here.
Sir, 5.
5. Done. No need to show this process here. This can be done in mind. This can be done in mind. So 23 square directly this. Let's take next example. I am taking this time 27 and I have to square. I will follow the same rule, but I will do everything in mind. What is B? What is B? What is B?
Sir, 7.
What's problem? Why do I need to ask two times or 3 times? What's problem?
But I don't know why my voice doesn't.
7. So 7 square is 7 square
Sir, 49.
49. Write 9. 4 carried. Now 2AB. A is 2, B is 7 and 2 is there. So do it. 7 2 ja 14. 14 2 ja
28.
and what was carried?
Sir, 4.
How much? How much was carried?
32.
How much was carried? Why so slow? What's problem? 2AB is 28. 4 was carried. 28 plus 4, 32. 2 came here. 3 carried again. Now what is A square?
Sir, 4.
4. And what was carried?
Sir, 3.
4 plus 3 is?
5.
4 plus 3 is 5.
7.
Are you sleeping? What's problem?
7.
What's going on? What's going on? What is 4 plus 3? What is 4 plus 3?
Sir, 7. Sir, 7.
What's wrong with you? Why are you sleeping in the class?
I'm not sleeping.
Did you understand this shortcut to square a number?
Yes, sir.
Okay. You have to practice more numbers, squaring like this. Now maths class ends here. Have a 5 minutes break. Join after that for science.